Hello, welcome to the 12th Real-Time Live. Like most of SIGGRAPH, this year's Real-Time Live is a new experience for us and for you. However, we've done our best to try and make it just as live as ever, even if it is a little bit more virtual. So each of the real-time demos you see today are being run live from their homes or offices in locations running from Seoul to Prague and in between. We did record a run-through with each of them earlier today, but we'll only use those as backup in case of a network outage, blackout, or other major disaster with one of the presenters. And I'm certain you'll know if something like that happens. If you're watching the show live, you will have the chance to vote on the Audience Choice Award at the end of the show, and to see that and the Jury Best in Show Award presented live. We couldn't put this show together without a lot of help, so I'd like to take a moment before we get started to publicly thank some of them. First is the Real-Time Live jury. These jurors watched and reviewed every submission to select the cream of the crop that we're seeing today. They're Ari Blankhorn from the Johns Hopkins Applied Physics Lab, Brian Brooks from Epic Games, Will McDonald from Amazon AWS, Andy Saya from Level X, Arissa Scott from Unity Technologies, and Rick Stringfellow from Electronic Arts Create. I'd also like to thank the Real-Time Live committee. These people spent countless hours putting the show together, and I'm immensely thankful for their help. I'm Mark Olano from UMBC and the Real-Time Live chair for this year. Chris Evans from Epic Games served on the committee this year and will be next year's Real-Time Live chair. Carlos Gonzalez from Epic Games did double duty as this year's game chair and also serving on my committee to help make Real-Time Live happen. And we had 3 regular committee members, Elizabeth Baumel from Unity Technologies, Don Engel from UMBC, and Luke Tannenbaum from Epic Games. Finally, these guys often go unmentioned, but I wanted to thank the Freeman team for all their work in pulling this off this live show. And of course, thanks to the companies who support Real-Time Live and allowed us to spend the time to make this show happen. As I mentioned before, if you're watching the live show, you'll get the chance to vote on the Audience Choice Award at the end of the night. The voting poll will go live at the end of the show on the SIGGRAPH conference page where you're watching this stream, and the award will be presented live on the stream. Since this is a live show, we're going to try for an additional bit of audience participation. The third demo tonight will be Drawmatic AR. That'll start about 15 minutes from now. Before we get to Drawmatic AR, we'd like you to tweet some ideas for food you might put in a picnic basket with the hashtag DrawmaticAR_RTL. Some of those ideas will be chosen live to incorporate into today's demo. But first up, we have an exciting blend of real-time AI, Formula One racing, and live television. From Virtually Live, we have Chroma tools, AI-enhanced storytelling for motorsports, for motor racing sports. This is work by Jesus Hormigo, David Daniel Aberacin Molina, Francisco Javier Vargas Garcia Donas, Jacinto Sevilla Esteban, Jose Castro Rios, and Jose Miguel Garcia Navarrete. The demo will be presented by Jesus and David. Jesus is the CTO, co-founder, and co-inventor of Virtually Live. He's currently developing and architecting a new age of immersive media that brings you into a real-world event and lets you participate in it real time. And David is a PhD student in computational intelligence. His research includes bio-inspired generative music and information retrieval techniques. He leads the research team at Virtually Live.
Hello, everyone, and thank you for tuning today into SIGGRAPH Real-Time Live 2020. My name is Jesus, and together with my colleague David, we're going to introduce you to Chroma Tools. Chroma Tools is an automated real-time pointing system that is used today in live television. Tagging different moving objects in live television has an incredible value because it adds context, which is essential for the broadcasters to tell their story. However, given the fast pace of action sports, shots lasts no longer than 2 to 3 seconds, which makes virtually impossible to handle this by hand in an efficient manner. There are also some technologically complex solutions out there using GPS, such in the case of NASCAR, but they are operationally prohibitive and definitely nothing that can be portable to other scenarios. Chroma Tools removes the technical barrier and eliminates the operational costs. Here's how we do it. We use synthetic images for training. It keeps us agile for last-minute changes if we need to change a detail here or there in the vehicles or the objects we want to track. After that, we generate 400,000 images to train our neural network, which is essentially an adaptive version of YOLO over Keras. Once we have the model, we update the inferencing computer and produce a real-time JSON feed that is sent straight to the GUI computer that sits on the production room. Live television is a very demanding and perfectionist industry. So delaying a few frames so we could buffer what's going on and compute our stuff could be an goal for the broadcaster. The system we're going to present to you today, it's actually strict real-time and fully autonomous, requires of no humans for operating. And we developed it in two variants. One is a full-fledged PC with an RTX 2080 Ti from NVIDIA that can render above 100 frames per second, has SDI connector, produces a chroma key and field that are standards in the broadcasting world. In addition to that, we also developed a smaller version that it's sitting on a Jetson Xavier and meets the real-time standards of 25 frames per second, producing in every frame, is tracking what's going on and placing it on the screen. As currently we have no live feed or event that we can plug into, I'm going to plug this recorded event into our system. So my colleague David right now will run you through the GUI and the operations. David, please go ahead.
Hi, thank you. This is the Chroma Tools user interface that produces the graphic that can be seen on TV. And what I have here right now is a fully operational system, the same used in television today. And all what you're about to see happens just in real time. As my colleague Jesus explained, there is an AI running in the background in the same computer and working on behalf of the TV producer. This software is being designed to work with just little to no human supervision. So after it's been set up, it can work 100% autonomously. Let's have a look at the typical workflow. Here is where we define the elements that we want to detect and the way we want the information to be displayed on the screen. So let me put SIGGRAPH here and also here. And afterward, you might be able to notice about this change. Of course, I'm doing this manually, but it can be automated connecting to online databases. Here, we can define layouts, giving the broadcasters full flexibility to organize the information on the screen. And finally, here is where we define the graphics that we will embed on the broadcast. These graphics, we call them pointers, and they look like this. Boom. Of course, all the setup that I've explained, it can be done beforehand, but I can change things now. Here, for example, I change the color, and the AI will point to the next element, applying the new configuration immediately. There are many options, quick hotkeys, widgets, AI-related parameters, all that to empower the TV producers to build their storytelling of the event. For example, one thing that they can do is define behaviors for the pointers. Here, they are at the top, and they point to the closest object. But I can choose a more traditional layout and stack the labels to one side of the screen. Or I can choose this cool mode, and the labels will go floating with the detected elements. Another thing, here on the left, I've created a placeholder of what a typical leaderboard would look like. This is so I can show you how to define safe areas, which are these blue lines here. And they essentially keep graphic away from overlapping on top of each other. Up to now, we've been used to these static and boring leaderboards and graphics on the sides of the screen. But now with Chroma Tools, we can let the AI tell us the story of what is going on in this Super Mario style. Isn't that cool?
Amazing.
And it also opens endless possibilities to connect external information to the tracked elements, such as position, fastest lap, sponsors, or anything really. And this hugely augments the information provided, which is quickly associated with what is happening, even for those who are alien to the event. If you want to know more, please visit our website at chroma.tools, and thank you very much.
Thank you.
Well, that really got us off to the races. As a reminder, tweet your picnic foods to hashtag DRAWMATICAR_RTL. So next up, from CTU Prague and Snap, we have interactive style transfer to live video streams. This one's also connected to a SIGGRAPH technical paper, so if you like the demo here, be sure to check out the paper as well. Contributors are Andrei Trexler, David Fuchek, Mikhail Kusera, Andrei Jamriska, Sarka Sokorova, Mengli Chi, Sergey Tolyakov, Daniel Sekora, and Pavla Sykorova. The demo will be presented by Andrei Trexler and Pavla Sykorova. Andrei Trexler is a PhD candidate at CTU Prague, in Prague, where he also received his bachelor's and master's degrees. His research interests lie in computer graphics, computer vision, and deep learning. In recent years, he did several internships with Adobe Research and Snap Incorporated. Now he collaborates with Samsung Research America as part of the Neon.life team. Pavla Sykorova is an artist working at the research lab of her husband, Professor Daniel Sekora, in CTU at Prague. She studied goldsmithing and jewelry at SUPS Turnov. However, her professional interests also include fine arts and interior design. Pavla is always excited to volunteer her artistic skills in research projects that seek to push the boundaries of what is possible.
Okay, thank you very much for the kind introduction. And again, hello everyone, and welcome to our real-time live SIGGRAPH session. So today we would like to present you a live demo of our SIGGRAPH paper, Interactive Video Stylization Using Future Text-Based Training. So first of all, let me introduce the setup. So I'm Andrei, and today I will be speaking, and I will be posing and smiling to the camera. And here's Pavla. She's artist, so today she will be painting my portraits. And a few minutes ago, we took a picture of me, and we printed this picture on a stencil right here. And now Pavla is drawing over this stencil, and she's producing an exemplar. And the goal of our approach is to learn the style, learn what Pavla is drawing, and apply this on my face. Here's the camera. Camera is capturing what's Pavla drawing. And the camera is connected to one NVIDIA GPU. And on this GPU, there is training running. And here's my laptop. And on my laptop, there is another camera capturing live video stream of myself, which is on the left-hand side. And in this is another NVIDIA GPU, and the inference is running there. And as you can see, the training started just 90 seconds ago, and as you can see already, the stylization looks quite good. So the network was able from scratch. The network is, in our case, is trained from scratch. There is no previous weights. It's from random initialization, and it was able to learn a lot of details, as you can see on the what's Pavla drawing. The main motivation behind our research was that we wanted to allow artists to iterate and prototype faster, because this is what artists want. They want to try their ideas really fast. So we wanted to come up with something interactive, easy to use, fast, and convenient for artists. And most importantly, we wanted to came up with a style transfer technique that performs style transfer, which is semantically meaningful. And what do I mean by semantically meaningful? For example, here, Pavla drew my mouth in a red color. And I expect that my mouth in the live video stream will also have red color, and nothing else will have red color, which is happening, so that's great. And well, actually, let's try to push this a little bit far. So actually, Pavla, could you draw my button in red color? Yeah. So Pavla just drew this this button on my face in a red color, and we will see how long does it take for the network to learn this change. And okay, so we see something already. So it took just a few seconds for the network to learn newly painted changes. And maybe could you draw the second button in green color or some? Yeah. So we are really pushing this quite far, and hopefully it will work. So what we want is to keep the red color of the first button and stylize the second button in green color, and it's already starting to show up. So yeah, cool. It quite works. All right, so let's see some other little bit extreme examples. So it also trying to do something on my hands and on other parts of my body. So my shirt will be somehow stylized, and even this network was trained only on this single style exemplar. It can stylize a little bit different images. Okay, yeah. So let's Paula, please change the template and let's start painting something else, some different style. So while Pavla is drawing another style, let's talk about some technical details. So how it's possible that it's so fast, and how it's possible that it uses only one training example. Because if we train a classical image-to-image translation network on only one example, the network would strongly overfit. So we had to come up with a technique that prevents this overfitting. So how we do that, we actually crop the one training example into thousands of small 32 by 32 patches, and we do the training on these small 32 by 32 pixel patches. And then doing the inference, because we want the inference to be real time, right? So we cannot do this on patches. It would be horribly slow. So, but thanks to the fact that our network is fully convolutional, it only has convolutional layers, we can take the entire image, entire video stream of myself and pass it through the network. And it's able to produce stylized images in real time. So yeah, maybe Pavla, could you draw something, maybe like lines on my shirt or something really, really strong, some really strong contours. Yeah. So let's see what will happen. And yeah, as I mentioned earlier, our network started training completely from scratch. So 30 minutes ago, the network had all the weights initialized randomly, and now it has learned how to perform the style transfer. And yeah, it looks quite nice. So yeah, if you like this, actually we have a full paper session on Friday. So, and we also release the source code. So just Google us. Thank you.
Well, I really can't wait until I can have that as a Zoom filter. It'd definitely be quite amazing for those bleary morning meetings. Meanwhile, next up is DRAWMATIC AR. AUTOMAGICAL AR content from written words by A-Reality 3D and Permute XYZ. This is the one that all your picnic food tweets have been leading up to. The demo will be presented by Yosun Cheng. Check out interviews with her this year and last year on the SIGGRAPH blog about some of her other work as a solo AR developer. Yosun's an augmented reality hacker, entrepreneur, artist who's been writing software since 1997. She loves building innovative software that uses emerging technologies to create magic. Indie for life, she's won too many hackathons. Her work's been shown at Ars Electronica, AWE, AWS reInvent, CES, GDC, Maker Faire, and many more.
DRAWMATIC AR is an iOS and Android app that turns what you write on real paper into a 3D AR interactive story. All right, so live demo time. I'm going to show you guys a few quick examples and then jump into that fun picnic collaborative story, real-time lifestyle. All right, first example is, all right, let's get to this node here. All right, so this is happening live on my iPhone. Okay, so you began by pressing the big button. In its simplest form, DRAWMATIC AR magically materializes key lexicon objects recognized. And you see there's like this AR highlighter for the words that are recognized. And even more interesting, you can actually learn how to say these in different languages.
Udi. Príncipes.
Principi.
Prinzen.
Prince.
And princess. All right. So, well, what makes these interesting is natural language processing. So in this case, since we have a story here, let's have this guy read it and draw my story. So yeah, once upon a time, there's our princess who lives in her castle. Let's actually go back to here and have it play.
Was once upon a time, there princess who lived in a castle near the sea.
Awesome. All right, let's go back to now mode. Oh, yeah, so you see the princess is actually correctly in the castle, and castle's placed by the sea. Awesome. Noun mode. So yeah, this is kind of a really quick intro to how dramatic AR works. AUTOMAGICAL AR content creation. No need to fumble around placing stuff. Let's do a longer, more complex story. All right, let's scan again, and let's do this. Okay, these are her subjects. So we're doing adverb animations for a barking dog, barking corgi, a climbing ninja, jumping wizard, a rabbit misspelled, and schemorphically you have the red line like a first grade teacher would do it. Polar bear, blue queen, so you have a blue queen, and a tiny unicorn, and then you have an elf likes hunting for treasure. So we're going to actually help her hunt for some treasure as well. This is an interactive game now where it's path navigating in real time, and we're also helping to hunt treasure. So basically SVO sentence analysis was done. So elf was parsed into hunting for treasure mode, and then you're playing with them. Okay, so here, and we can do on the word. So this way it's going to actually show, let's actually show directly what's happening. This is in demo mode here. So instead of just showing the characters right now, we are seeing what each word is recognized as. So you have the pronoun and then the verb, the participles, and nouns, and yeah. So we have kind of cleverly this AR marker disguised as a magic worksheet. And so this means that the TensorFlow handwriting analysis to text gets, works on pretty much any angle, very robust. Okay, anyways, let's go back into regular mode again. And so here we go. And focus. Okay, right. So cast of characters. All right, let's get to our live demo. This is the fun part. Well, everything's been live so far, but this is the part where you guys have been queuing up your things for, okay? And I'll try to go chronologically. I'll try to get everyone, hopefully, depending on how fast I write and how bad my handwriting gets. Yeah, so let's see. Sandy Wrestler says hot dogs. And this is all directly from the DRAWMATICAR_RTL hashtag on Twitter. And then wear a mask says prawns, okay. And then Elizabeth says pie, okay. I'm gonna add some commas, I guess. My handwriting is really bad right now. And then let's see, donate money to people who need something. It says our charcuterie board, okay. Okay, fancy. Let's see. And then Epicenter wants cheese. And Gracie wants a bottle of wine or fruit. Okay, let's do bottle of wine. Let's see if that blows up. It's for kids, so it's not supposed to have any alcoholic things. Okay, anyway, so fruits, and then did I write cheese? Okay, there's charcuterie. We'll just write cheese. So there's like extra, milk products. And all right, Anna wants brie. All right, we're running out of time. So let's, there's actually a lot more we can do, but due to the interest of time right now, we're going to just jump straight into this. And picnic basket, here we go. All right, ready to go. Hot dogs, and then, well, I guess my prawn was really bad handwriting. Pie, charcuterie, cheese, bottle of wine. I guess the interpreted wine as a, yeah. Anyway, that's straight from Google Poly, actually, community created 3D content, and my brie is really bad handwriting. Anyway, so this is the beginning of a future of interactive storytelling that goes straight from word to, a magical storytelling. And this is DRAWMATICAR is live on the apps from Google Play. Buy it to support the new developer. And yeah, cool, awesome. Design Instinct and Corgi.cam, Permute.xyz. Thank you.
Well, the food's great, but I have to agree to the one tweet I saw that no picnic could possibly be complete without an army of ants. Next up, we have introduction to real-time user interaction in virtual reality powered by brain-computer interface technology. This exciting new tech brought to us by Anna Jo, Brian Yewok-Che, and David Shin from Lumix Labs. It'll be presented by Anna Jo and David Shin. Anna is a marketing and communication team leader at Lumix Labs with over 8 years of experience in product marketing, branding, market research, product development, and public relations. She majored in neuroscience with a BS and MS degree. And David's a product manager at Lucid Labs. He's currently responsible for demonstrating Lucid products and communicating with customers. He has a BS degree in electrical engineering.
Thank you. Hello, everyone. I'm Anna, and this is David. We both work at Lucid. Today, we will introduce a new tool called Lucid Link, which will personalize the user experience in virtual reality. As the introduction said, I'll be covering the technology and tools to capture and interpret biometric data on human behavior through VR interaction in real time. In VR, because the head-mounted display is in contact with the forehead, we can acquire biometric data like brain activity to capture aspects of the user's minds, such as cognition and emotion. When your brain is in a certain state of mind, the frequency patterns of the brainwave change, such as a small change of voltage in the brain, giving insight into the cognitive process. So, here we have the Lucid Link platform, which is a brainwave sensor module that can be attached to major VR headsets such as Oculus Rift S and HTC Vive Edition, and are ready to use Unity API. Lucid Link platform is able to provide users mind indices such as attention and relaxation. While the user wears the VR headset and uses VR applications, Lucid Link acquires the user's brain waves and delivers the user's features like alpha, beta, delta, gamma, and theta waves, and mind indices by analyzing the captured biometrics in real time. Okay, so guys, now I'm gonna start to show our apps that utilize biometrics to visualize, interact with, and analyze users' minds in VR. David, before using the device, David can check the sensor status tab to make sure all sensors are attached properly, and not only observe real-time streaming of the raw EEG signals, but also check the respective brainwave frequencies for each sensor on the Feature Index tab. The first thing we are gonna do is try the VR MindCare app we have developed. It's a guided meditation session that helps the user relax. During the session, you will sit at the circle, and the color of the circle changes according to David's state of mind. If the circle is green, this indicates that he is relaxed. And if the circle is red, he is stressed out. He is breathing in as the circle expands and breathing out as it contracts. All right. Let's move on to the second image on your left side. What we are gonna test is a simple interaction app called the Interaction Playground that visualizes users' minds in VR. Those are David's brain signals right now. In the Mind Index tab, you can see its attention and relaxation levels, as well as his left and right brain activity figures. We can make more boxes by pressing the side button of the controller and start exploring the space. As soon as David is focused on one of the boxes, you will notice that boxes will rise and reach the ceiling. As soon as David gets distracted, the boxes will fall to the ground. He can choose between attention and relaxation, or select the frequency band for a specific sensor to levitate the boxes. Levitating the boxes is harder than it appears. Let's go back to the home screen and take a look at the last step, Mind Master. David will be able to create a fireball once he focuses. Here we go. He will create a fireball to its maximum potential of 100 or grab it at any time he wants. To grab the fireball, he will move his controller to where the fireball is located and hold the trigger button. To aim, he will need to move his head around and place the controller. And place the red dot on his target. Now to draw the fireball, he will need to swing the controller. While David is forming a fireball with his deep focus, this dragon is also still attacking David. He can avoid the dragon's attack by dodging and continuing to attack it until its health points are depleted. Okay, cool. Just like this, our tool can be utilized as a user interface to connect users' minds to VR. Thank you.
Well, I think I was paying a little too close attention to that one and almost hit my computer with a fireball. Next up is AI-synthesized avatars, from real-time deepfakes to photoreal AI virtual assistant, by a big team at Pinscreen. And I was going to read all of these, but given that it's 2 columns of names, I think I will limit myself to just the 3 who are presenting. So it's going to be presented by Zizhan Wang, Lane Goldthwait, and Hao Li. So Zizhan is a senior software engineer at Pinscreen. He leads the development for Pinscreen's new release of the AI face rendering Pagan 2 demo today. Lane is a senior software engineer at Pinscreen. She won the BAFTA in 2016 for her work in game development and was a semi-finalist in the Microsoft Imagine Cup that same year. And Hao Li is CEO and co-founder of Pinscreen. He was named top 35 innovator under 35 by MIT Technology Review in 2013 and won the Office of Naval Research Young Investigator Award in 2018.
Hey, thanks for the intro, Mark. So hi, everybody. My name is Hao Li. I'm the CEO and co-founder of Pinscreen. And today, goodness, what is that? Will Smith? Oh my God, Will Smith is in the chat room. Oh my God, what are you doing here? Where are you?
Hey, how surprise. I'm Emo.
Ah, it's you. Man, you just look like Will Smith. What's going on?
Yeah, I'm at Pinscreen office now, and I'm trying a new real-time deepfake technology here.
This is insane. How does it work? Can you explain that to me?
Yes, all I need is a webcam here, but also I need a powerful PC. I'll explain why in a minute.
Okay, okay. And you can just like turn it to someone else like that?
Yeah, let me show you how it works. So firstly, I need to create a 3D face model of myself. Now it starts to tracking my face at pixel level. Now I just need to go to the UI, and now I turn myself into Will Smith. So we firstly need to train a deep model of Will Smith's face using several minutes of YouTube video. And then using our new face rendering technology called Pagan 2, we can render the face and compose it back onto myself. As you can see, not only the facial expressions, but also other features like teeth are generated in real time.
Wow, that's crazy. I just saw you had the screen with a lot of different people. You can just switch to any of them?
Yeah, let's try.
All right.
Let's try Leonardo DiCaprio.
Oh, that's exactly him. Come closer to the cam.
Yeah, and also soccer star
Lionel Messi. Yeah.
Or even George W. Bush.
Nice. Hey, the weather looks like pretty nice in LA, so you have this really good lighting condition. What happens if the light goes really bad? Like, is it just going to look like a sticker to your face? Can it adjust to the lighting?
Yeah, let me show you with the lights move around my face. So as you can see, the face is changing based on the environment light.
Okay. Oh, it works really nice. So I read a lot about deepfakes, and you know, it seems like whenever you have to use it, you have to train like every subject. You have to train their models. You have to collect a lot of data and train overnight. Do you have to do the same thing here?
No, this is the many-to-one face replacement technology. Anyone can sit here and try the demo. Actually, Lane, would you try here?
Oh, yeah, let me jump on. Yeah, that's
Cool.
great. Yeah, so I can actually just sit down here and let's see, I'll just click here and it's already tracking my face. So no need to retrain for my face. It just works for my face. So that's pretty cool, but I wonder who I want to be. Maybe I'll try being a K-pop star. Whoa, that's pretty crazy. How about Theresa May? Whoa.
Oh my goodness.
Yeah. That's pretty cool. Let's get really adventurous. Let's try DiCaprio. Oh wow, I don't know. I think DiCaprio is better on your face, Emo. Let's try having you come back on. Yeah.
Okay. Yeah, thanks for the demo. This is pretty incredible. So you know, it seems like you guys can just like turn into anyone you want, and I can see a lot of potential, you know, dangerous applications with that. But why do you guys develop this at Pinscreen?
Yeah. So. Yeah, so let me explain. So basically, at Pinscreen, we're really interested in creating a super convincing autonomous virtual companion. And we want to overcome the uncanny valley. And so to do that, what we've done is we've incorporated our Pagan 2 technology into Unreal Engine 4, which is really awesome. So here, how we actually even created a virtual avatar of your wife. You want to talk to her?
No way. Yeah, let's do it. Let's do it. How do I get started?
Yeah, so just open up the browser on your computer.
Okay.
Mm-hmm. And once you got it open,
all right,
you should be able to press play, and you should be able to see Frances's virtual avatar.
Oh, wow.
Yeah, there it is.
Exactly like her. Let me move the camera around.
Yeah, so it's a full stack AI solution, and it's entirely cloud-based. We stream it directly to your web browser. Okay. So now you should just be able to press start recording, and you can talk directly to your AI wife bot.
Okay, let me try that. Hey, how are you? Can you hear me?
I cannot hear you. I can only hear you say hello to yourself. I don't know who you are.
I'm your husband. Hey, we're at the live conference at SIGGRAPH. There's a lot of people watching you. You're famous.
How old are you? Are you married? Is the marriage young? What will you do with the money you make?
Well, that's a very indiscreet question. Hey, do you have any plans this weekend?
I am not sure. I do not know. Maybe I should go see a movie. What would you do?
I guess I'll be relaxing a little bit. I've been working a lot.
What are you working on? Maybe you should get a job. Do you enjoy your work?
Yeah, I do. We're working in artificial intelligence. Are you scared of artificial intelligence?
I am scared of robots. I'd like to work on a robot, though.
All right. Okay. We're going to say bye and then move on to the next show. Thank you.
Yes. So.
All right. So thinking about those early morning Zoom meetings, maybe a deep fake of myself would be a better choice. I'll have to get Pinscreen started on that one. Next up is limitless dynamic landscapes of 1 millimeter per pixel density, zooming included, by Unigen. Contributors are Michael Lubimov, David Vidiger, and Dennis Sturgeon. It'll be presented by David Vidiger and Dennis Sturgeon. Dennis is the CEO and founder of Unigen with 20+ years of experience in IT, vast experience implementing real-time 3D technologies for both enterprise and entertainment projects, and has produced a series of GPU benchmarks, the Oil Rush game, and plenty of professional simulation and training projects. And David is lead technical artist at Unigen, engaged in activities from new shader effects to the tools pipeline, and is co-author of the SSRTGI technique presented at SIGGRAPH 2017.
Hello, my name is Dennis Sturgeon. I'm CEO and founder of Unigen, and together with me is David Vidiger, lead technical artist at Unigen. We have a lot of experience in building terrain technology for the simulation and training industry, with 4 major generations already implemented in our Unigen engine for the past 15 years. However, recently we got a new pack of requirements from customers, and here is the list. Simultaneous editing by a team of 3D artists, iterations on manual modifications mixed with the procedurally generated data, unlimited number of materials, dynamic modification of the terrain geometry in runtime, support for binoculars, zooming, and so on. And the special part for all of these requirements is that the terrain must be very, very large, hundreds and thousands of kilometers in size. This is a typical case for professional flight simulators, for example. And we completed the required technology last year. Today, we are showing you a Mars demo powered by this terrain. The demo is created on the basis of a real Mars data. Gale crater in particular, that's where the Curiosity rover is now. The challenge here is not only the runtime implementation, but also the content workflow and the toolset. The foundation for the non-destructive collaborative editing is the concept of data layers, which are blended into the final terrain. Each layer contains height and mask information, and it can be moved, rotated, or scaled independently. It's very convenient because you can separate procedurally generated data from third-party software and make individual layers for different team members. These layers, called landscape layer maps, are stored as individual sets of files, so there will be no conflicts with the version control system. Insets. This Mars scene is 1,000 by 1,000 kilometers in total size, while the area of interest has a smaller size, so it makes sense to use different data resolution, a so-called multiple insets approach. Here we have 3 nested insets, 1,000 by 1,000, 40 by 40, and 80 by 8 kilometers in size. Dynamic modification. If you want to make a trench or a crater, simply place a ready-made landscape layer map there. Same thing with traces from reels. Spawn small layers underneath, and it can be done via API in the runtime as well. The virtual texture approach seems to be a natural choice here. We use a special sparse texture which is updated on the camera movement or on or terrain update. It consists of multiple tiles of 128 by 128 texels in size. We are baking details into 4 huge virtual textures: height map, albedo, normals, and roughness. This data is rendered to the screen buffers. Once the tile is streamed into VRAM, we need to position it in the scene. For typical game engines, with flow at precision of coordinates, it's okay to have a regular index texture for addressing tiles. But we work with huge locations, and the Unigen engine supports double precision of coordinates, so this index texture can be way too large. So we used a hash table instead, which allows us to get a tile ID for any position in screen space. This function also has a MIP level as an argument. As we deal with very high resolution data up to 1 millimeter per pixel, there must be asynchronous data streaming. As the technology is future-proof, it is designed primarily for the use with SSD storage, and the system is working in a multi-thread mode by default. Data streaming has a very rich set of parameters. Basically, we are trying to balance between overall performance, I/O load, VRAM consumption, and visual quality. The most extreme case for a data streaming system is a dynamic zoom feature. Well, when you have a very narrow FOV, 1 degree is typical for a UV camera, you deal with extreme camera movement speed, so there is always a situation of complete cache invalidation. Data streaming must be super efficient to keep up with the camera. Universal masks. In Unigine, the train has a universal mask system. Each one of them can be used not only to form visual representation, but also can store semantic data. For example, you can store surface classification data there and use it in the app logic, have different friction behavior, or store temperature data for thermal sensors move. In this demo, you can see that the amount of dust generated depends on the surface we are driving currently. As for the performance, it heavily depends on whether the stream is active or not. If you render the cache styles, it is almost the same as rendering a static plane with tessellation. When streaming is active, the overall performance cost might be up to 1 millisecond and more, depending on the settings for 4K frame on RTX 2070. So it took almost 2 years to create this technology, and it is now an integral part of Unigine engine, which is available for free download at unigine.com. We would also like to thank our third contributor, Michael Lebium, who is the main programmer for the system. So you can download some demos and as a key from unigine.com today and play around with the technology. Thank you.
So if I've been stuck at home for too long, if I really want to visit those wide open landscapes, even if they are on Mars, I don't know. So next up is Sketch to Art, synthesizing stylized art images from hand-drawn sketches with no semantic labeling from ArtRendex and Rutgers University. You can find a paper with technical details on archive. Contributors are Ahmed Elgamal, Bin-Chen Liu, and Kunpeng Song. It'll be presented by Ahmed Elgamal. Ahmed's a professor of computer science at Rutgers University and the director of the Art and AI Lab at Rutgers. Dr. Elgamal is also the founder of Playform, a platform that enables artists and creative professionals to explore integrating AI in their creative process. Dr. Elgamal has a 25-year career as an AI and computer vision researcher with over 180 peer-reviewed papers. In 2016, a TV segment about his research produced for PBS won an Emmy Award.
Thank you. Hello, everybody. On behalf of the whole Playform team, I'll be presenting Sketch to Art today. So before I dig into Sketch to Art, for those of you who don't know Playform, basically a Playform is a creative tool that allow artists to collaborate and create AI art. Artists can create and explore and experiment with AI in their work. So Playform allow you to train your own model from scratch. So just upload your images and get real-time generation. You don't need to go to upload as little as 30 images, and the AI can be trained on these images. We also optimize the process such that you can have the AI model trained in an hour or a couple of hours at most. Training from scratch means that you will not have any built-in bias from pre-trained models. As an artist, you get results only purely based on your own inputs. Another tool we developed in Playform is Face Mix. With Face Mix, you can mix photorealistic and illustrative faces with ultimate control. You can control and edit various facial attributes in real time to create the exact face you want. You can control the expressiveness of facial attributes. For example, here we mix Kim Kardashian West, Kanye West, and Northwest images to create a prediction of how little Northwest might look like when she is in her 20s. So now let me switch to the demo part for Sketch to Art. Sketch to art allow creative to sketch an idea and render a fully colored and textured image based on the style they are looking for. First, user have to choose what genre they work with because it's how the AI interpret your drawing. For example, user can choose landscape, still life, composition, serial composition, photorealistic faces, anything. So let me start with a landscape, and I'm creating a new project here, and let me start drawing something here. So let me just draw a foreground here, and maybe some hills, and maybe a mountain here, more hills, and maybe a background, mountains. So I'm not gonna tell the AI anything. I just draw, and the AI has to has to guess what I'm drawing based on what it learned. So then I can choose what style I'd like to do. So I can upload a reference image or a set of images, or I can use any pre-trained models for artistic movement or a specific artist or a specific artwork. So let me try Post Impressionism, for example. Once I click the Generate button, the AI will start interpreting what I draw and start generating options for me about this interpretation in the post-impressionist style. Let me now try something different. Let me try expressionism. I'm expecting here something that will be bold in colors and have a strong contrast and maybe more flat areas. So yeah, here what you get. So much different. Or I can choose a specific artist like William Turner and generate images to try to find out something foggy and dreamy and more realistic. So I got some interesting results here. Finally, let me try my favorite artist, Nicholas Roerich, simplest artist. And I get the effect I'm looking for. So let me now switch to do something different. So let me now do a still life, for example. So I'm going to start a new project now in a still life. And let me start drawing something. It's much harder to draw something in a still life. So I'm going to start drawing potted blend, for example. And draw a table maybe, and some flowers. As you see, it's very crude drawing, and the AI hopefully will understand this and give me something interesting. Let me just choose post-impressionism again. And here you go. So many nice, interesting results. So let me improve my drawing now and start drawing something on the table, maybe some fruits and maybe some chair. Can add whatever I like and generate again. Again, in a few seconds, the AI will generate many more results for this. Finally, let me try a specific artist in the last few seconds. Let me try Bonard. So everything here you can try yourself. Just to go to playform.io and try all these tools yourself. Thank you very much.
Well, for anyone who knows me, I can write a shader, and I've been known to do some lighting design, but putting paint to canvas is definitely well outside my skill set. And I think with something like that, even I could be an artist. Next up, we have volumetric human teleportation by a team at the USC Institute for Creative Technologies and Pinscreen. Contributors are Rulong Li, Kyle Oshesky, Yuling Zhu, Shunsuk Sato, Zhang Wang, and Hao Li. It'll be presented by Rulong Li, Kyle Oshesky, Yuling Zhu, and Zhang Wang. Rulong is currently a second-year PhD student at the Vision and Graphics Lab of USC, advised by Professor Hao Li. His research interests lie in the intersection of computer vision and graphics, especially in representation of learning of the human body and face. Kyle Olszewski is a PhD in computer science at the University of Southern California, working in the geometric capture lab under Professor Howley. His research focuses on real-time facial expression tracking, particularly using techniques suited to emerging platforms such as virtual and augmented reality. Has been published in venues such as SIGGRAPH, SIGGRAPH Asia, ICCV, CVPR, and he's a former senior software engineer from NVIDIA, and as a student has been a research intern at Oculus, Adobe, Microsoft Research, and Snap. He was also a recipient of the Snap Research Fellowship. Yulong Zhu is currently a second-year PhD student, also in computer science at the University of Southern California, also working in the vision and graphics lab with Professor Howley. His research interests are in computer graphics and computer vision, especially 3D geometric human reconstruction and 2D visual human understanding. And finally, Zheng Wang is a PhD student in computer science at USC, focusing on computer vision and graphics. His most research effort has been focused around volumetric reconstruction for virtual humans, combining geometry processing and deep learning. His thesis on reconstructing the clothed human body in the wild with great detail for minimal input on cameras.
Okay, thanks for that introduction. I'm Kyle, and today we're going to introduce the first system for real-time volumetric teleportation, or monoport for short. So to motivate this, just think for a second about the way we're communicating right now. I'm streaming to you online through this webcam. You're watching me on this 2D display. Now, this is all right, but I mean, after several months of this, you kind of get the impression that this is really kind of lacking some really immersive social elements. So you might ask yourself, is there some way that we can actually interact more socially in some sort of safe, more compelling, really more immersive environment, like say an online virtual environment, like the ones they have in games like Second Life or World of Warcraft? Now, there are AR and VR displays that allow for really like compelling ways to traverse and render these scenes in these environments. But what they're currently lacking is the ability to rapidly create and render complicated 3D content like the human body, which you really need for sort of immersive telepresence applications. So basically, we can see 3D data, but what we can't really do is actually create it quite easily. So that's where Monoport comes in. Now here you can see on the main screen, the main demo of our app. You can see there Yulong is doing a variety of poses while he stands in front of just a standard Logitech webcam. And on the right, you can see on the top the captured inferred texture of his body, and on the bottom the geometry with the normals. And you can see as it's rotating, as he moves around and does different poses, it automatically adapts to his new pose and even infers regions that can't be seen by that single camera. Now, there have been approaches to do real-time performance capture and 3D reconstruction in the past, but they've had limitations like requiring multiple calibrated cameras, which isn't really tractable for standard settings, or requiring this carefully pre-captured template of the subject, which means you can't even do things like, say, change your clothes, alter your appearance, grow a beard, without having to go through some new calibration. With our system, we actually allow for monocular performance capture without a template while performing real-time volumetric reconstruction and rendering. And again, this is just using commodity desktop hardware. It's using a simple Logitech webcam, capturing him at SDs, so 640 by 480, using 2 NVIDIA GPUs to render and reconstruct in parallel. And so this sort of builds on some work from last year that our lab introduced called PaiFu, which can actually create an implicit representation of a person that can then be rendered and reconstructed. But unfortunately, the volumetric reconstruction was really too slow to be used for these sort of real-time environments. For this year, we accelerated this process using accelerated octree-based rendering and reconstruction algorithms, as well as new training techniques that make the system more robust to a variety of users like shapes, appearances, and all the different variations you see for like real performance capture. So these traits really allow us to do a lot of interesting things we'll kind of show off to you now. So Zheng, would you like to step in? Just switch places with Yulong for a sec. So because there's no template required, we can automatically switch the subjects. You see as Yulong steps out and Zheng steps in, the system automatically just calibrates to capturing him frame by frame. And you can see again, it infers the missing regions, follows his performance, captures both the geometry and the texture. And it also can even adapt to changes in his appearance. So Zheng, if you want to go ahead and just remove that hoodie you're wearing, you can see as he does that, it just dynamically adapts to how the hoodie goes away. You can see his t-shirt now. You can even capture a little bit of the geometry of the hoodie as he takes it off. And again, just sort of adapts, so we don't really need to do any recalibration, capturing of a template. We can also introduce things like props. So if you want to go ahead and like pick up that backpack nearby you, can handle like everyday objects in a way that some standard template with just the human body on it can't really handle. It's also robust to changes in the lighting, so you can kind of see how Yulong is just adding some sort of like rave style lighting effects there. It's maybe a little bit subtle, but the system is quite robust to all these different variations. And if Yulong, can you just step back in? So that covers the whole reconstruction and rendering thing I've described to you, but the thing you might be asking about is this whole teleportation thing, like how does that come in? So the idea is with this captured geometry and texture, we can actually teleport our subject into these new virtual environments. And to do that, we actually have introduced this or built this app that you can see right here. It's simply just kind of a lightweight iPad app, which automatically, once we capture the geometry and texture, we can stream that to this app. And then as the orientation of that iPad changes, we can change the point of view, kind of like you would if you're like, say, navigating through some virtual environment here. And because this is some arbitrary virtual environment, we can even do things like change the background. So like you want to change the setting. Roy, if you want to go ahead and maybe just toggle through a few different backgrounds, you can see how we can choose like different environments to put them in. So you can imagine this could be anything from your just sort of boring old office that you're maybe kind of missing at this point, or something like, say, like a World of Warcraft fantasy world setting. And interestingly, one thing we noticed when we were experimenting with this system is that even though it's only trained to capture one subject at a time, it can even actually capture multiple people during inference. So Zheng, if you'd like to just go ahead and step back in next to Yulong. You can see again as Zheng steps in, stepping in there. Yeah. So basically, as he steps in, it automatically starts capturing their geometry and texture again, streaming it back to the iPad app. And once again, it adapts to their performance, their like changes in pose of the camera, their appearance, like their motion, all that's just being captured and streamed dynamically to this iPad app. So in conclusion, in this age of social distancing, where I think we're all getting really hungry for some more like immersive social contact that's very safe, I think that something like this is going to be like really important both in the near term and probably in the long term for like telepresence, where you want to talk to your relatives on the other side of the world without having to get on a plane, even when that's technically safe. So in conclusion, that's Monoport. If you're interested, you can check out the QR code there. If you look us up online, you'll find there's actually an ECCV paper being presented this week on the kind of background algorithms for this. And we also just released the code for this demo if you'd like to try it out yourself. So once again, that's Monoport. I'm Kyle, and thanks for your time.
So that's all the presentations for Real-Time Live 2020, which means if you're watching the live show, now it's the time for you all to vote on the Audience Choice Award. If you're watching full screen, you want to pop back out to the main page to make your vote. The vote poll should now appear in the bottom left side of the screen. Meanwhile, enjoy this 5-minute retrospective of prior year shows while you're making your decision, and we'll come back as soon as it's over to announce the winners of the Audience Choice and Best in Show Awards. All right. So we're back. So without further ado, the Audience Choice Award goes to Dramatic AR. Thanks to all the presenters for an amazing show. Though we'll give 2 awards today, all the presenters today were incredible in my book. Now, I want you to imagine them walking towards the stage to accept their award. We don't have a live stage this year, but switching around the video feeds to bring them up to accept their award still isn't instantaneous. Hopefully it won't take too long to get Dramatic AR into the stream to accept the award. Certainly, you should, if you have any excellent interactive content that you were just dying to show, you should consider submitting it for next year's Real-Time Live. Real-Time Live, as you can tell from the contributions this year, is driven by developers both large and small. So everyone from giant Disney attractions to our Audience Choice Award, Dramatic AR, which is a single-person AR project. And I think I see a little bit of a corgi right there.
Oh, did it work?
Yes. So congratulations.
Really go out. And the air quality actually has dropped to 78 from like 150, which is amazing in the last hour.
So you can say a few words. I have no idea
what's going on right now. Is the Zoom thing working? I can't hear anyone. Thanks. Yeah. Cool. Awesome. Cool. All right.
We seem to have lost the Dramatic AR. I'm not sure if they'll have her back. I'm seeing on the side that she can't hear us, and they're trying to get her back. Okay. In that case, through yes, the wonders of live of a live show, right? Okay, so we have the other award to give, and I guess I can go ahead and do that one. The jury award. Let's see, and of course, this one I have to actually count, unless someone off camera is doing that for me. I apologize for the delay. Looks like the jury award goes to Volumetric Human Teleportation in a tie with interactive style transfer to live video streams. So we have a tie in our Best in Show award. I'll let the video crew pick one of those to maybe bring in to accept their award, and then the other one. Here we have the interactive style transfer. So congratulations. Would you like to say a few words?
I'm from the Volumetric Teleportation project.
Oh, you're right, you are.
Fair enough. Anyway, yeah, I mean, thanks. It's really an honor. But yeah, I mean, great work to everybody involved. I mean, Hao, Shunsuke, Zhang, but also especially to Ruilang and Yulang. They're the ones who kind of led the project. They're the ones who led the project for the paper that's related to this. So yeah, I mean, glad to see everybody really liked the work. I mean, I also thought it was really awesome work, and I'm really proud of the work that they and everybody in the team did pushing this forward, both in terms of like getting the demo ready, but also just the kind of core work of, developing the paper, all the results, and I really do think this is going to be an interesting step forward for state of the art for like this weird new age of social distancing we're in, which is, I think, driving us all a little out there. But thanks so much for that. And did you want to bring in the other guys too, or?
Yeah, let's go ahead and bring in the second winner to accept as well.
Thanks again.
Thank you.
Mm-hmm.
Yes, so I hope you can still see my screen. So actually my camera is mounted to this live video stream. So thank you very much. We are really glad that we received this award, and it took us enormous effort to create this research project, and it also took us a lot of effort to prepare for the real-time SIGGRAPH session. So we are really glad, and we are really tired. And thank you very much.
All right. Well, thank you. Thanks to both of you. Thanks to thanks to everyone. It sounds like I'm hearing that we may have the Dramatic AR back to for the Audience Choice Award. So why don't we cut back over to her for a minute so she can say whatever she wants to, and the corgi can accept the award, right?
All right. Hi. Yeah,
Hi,
this was unexpected, but thank you. And thanks for collaborating in our super fun virtual augmented reality picnic online. I just want to say this is the first step in what I believe is a new kind of future for storytelling, where you can go directly from spoken or written words, like from script straight to production. Of course, this is the very first step, and we're starting with first grade. In 10 years, I think this AI can pass AP English or something, and eventually you can have, multi-million-dollar productions that are basically automatically created from AI, straight from your story words. I think that's even like right now, a common problem with augmented reality is you're placing things, and placing things is kind of a pain. A lot of these automated placement things can also directly be applied, and these. It's kind of a small advance. It's a fun sort of side project for me, and it's something I hope to kind of work on some more, hopefully. We'll see, where it develops next year. Download the app on the App Store. It's Dramatic AR. It's also on Google Play. Help support this crazy one-person indie startup studio, Permute.xyz, aka me. It's really interesting. The air quality actually dropped from 150 to it's 78 in the last hour or so. I guess it's time to go for walkies, right? Yeah, walkies.
Oh well, perhaps I should let you go ahead and do that, and we can wrap up Real Time Live 2020. Thanks again to our jurors, committee, sponsors, presenters, everyone who submitted, and of course you, the audience. And once again, if you have any amazing real-time work to show, remember to submit it for next year's show. And we'll see you all in 2021.